Good morning, remote learners. This is Mr. Heichel bringing you some of that ionic bonding notes that you missed directly in class yesterday. I'm just going to go over this sheet. I'm going to fill it out with you. I'm going to upload this same document to Schoology. If you want to print it off and fill it in, highly suggest you do. If not, this is just going to be your notes that you're going to need to do your work. So first thing we're going to talk about is valence electrons. All valence electrons are electrons in the outermost energy level. So they're located in the outermost energy level of an atom. All the electrons we're going to be talking about from here on out are going to be concerned with being valence electrons. So elements in these same, you got groups that run up and down, and you've got periods that run left to right on your periodic tables. So elements in the same group are going to have the same number of valence electrons. So then we're going to talk about Lewis dot structures. So Lewis dot structures are simply a way to represent valence electrons. They start with the elemental symbol, and then you put dots to represent each valence electron. You find valence electrons by the group number. If it's greater than 10, you subtract 10. So calcium, if we look on the periodic table, is in group 2. So it's going to have 2 valence electrons. So we're going to start on the right. We're going to go right, down, left, and up would be our pattern. So since it only has 2, we just put 2 dots. Magnesium is in the same group as calcium, so it's going to have 2 as well. Carbon is going to be in group 14, so it's going to have 4 valence electrons. And so we go right, down, left, and up. Carbon has 4, so it has 4 valence electrons. Sulfur is going to have 6 valence electrons, so it's going to have 6 dots. So 1, 2, 3, 4, 5, and 6. Bromine has 7, so it's going to look very similar to sulfur, but it's going to have 1 more dot, so it's going to have 7 dots. Neon. Neon is like the element that all elements want to become because it has 8 valence electrons. All elements want to get to 8 valence electrons. It's in group 18, so we're going to subtract 10 from that. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8. Which takes us to the next question of why do elements form chemical bonds? They form chemical bonds because they want to get to 8. 8's their magical number. It's when they become unreactive and they kind of found their soulmate. Let me change to a pen because this pencil is kind of light and I don't want you to miss something. So ionic bonds form through what's called a transfer of electrons. Either Thursday or Friday, I'll put up your covalent notes. Covalence is the sharing of electrons, whereas ionic is the transfer of electrons. So ionic bonds perform between what's called a metal, which is to the right of the stair step on the periodic table, and a non-metal. So this isn't on the notes, but I told the kids to write it in that we're in class. So covalent is non-metal and another non-metal. So it's between two non-metals. We're going to need this part for these questions over here. So we're going to determine the type of bond that will form between the following. Carbon is to the right of the stair step. It's considered a non-metal. And oxygen is also a non-metal. So this bond is going to be what's called a covalent bond. Calcium is a metal. So that's going to be an ionic bond. Nickel is also a metal. So it's going to be ionic. Phosphorus to the right of the periodic table. It's non-metal. Fluorine is also a non-metal, so it's going to be covalent. Lithium is a metal, so ionic. And strontium is a metal, so it is also ionic. An ion is an atom or molecule that has a charge. It simply has a charge. It's either positively charged or negatively charged, and we're going to determine that here on these next set of questions. So a polyatomic ion, if we break down the word polyatomic, poly meaning many atoms that have a charge. So polyatomic ions are just many atoms together that have a charge. Many atoms together that have a charge. So metals, since metals only have 1, 2, or 3 valence electrons, and they're trying to get to 8, they're going to lose electrons. So they're going to lose electrons, which are negative, right? So if they lose negative charges, they're going to become positive. These are called cations. Inversely, nonmetals do everything completely opposite of their metal counterparts. So they usually have 6, 7, or 8, or no, sorry, 5, 6, or 7 valence electrons. So it's easier for them to gain electrons and get to 8 than it is to lose. So they're going to gain electrons. They're going to become negative. They're going to be called anions. So then let's look at this chart at the bottom just to kind of summarize everything, and then you'll have some practice problems that you're going to have to do on your own. So lithium, the symbol is Li. It is a metal. It's in group number 1. It's going to have 1 valence electron, so our Lewis dot is going to be an Li with a dot. So since it only has 1 valence electron, it's going to lose 1. It's going to become a positive 1, and it's going to form what's called a cation. If you just want to write cat, that's fine. Phosphorus, its symbol is P. It's a non-metal. It's in group number 15. Remember, we're going to subtract 10 from that to figure out valence electrons. So it's going to have 5 valence electrons. Its dot structure is going to be like that. It's going to gain 3 to get to 8, and it's going to become negative 3, and it's going to be an anion. This is supposed to be strontium. Strontium is Sr. It's a metal. It's in group 2. 2 valence electrons. Sr, 1, 2. It's going to lose 2, become positive 2, and it's going to be a cation. So I'm going to go ahead and give you some examples of your other work while we're at it. How to make these electron dot formulas and how to actually make bonds. So on this one, I want you to show me the actual bonds and how they work and the formulas and all that good stuff. So we're going to start with lithium. Lithium is Li. It's going to have 1 dot because it's in group 1. Chlorine is going to be over here. It's going to have 7 dots because it's in group 17. So this lithium, we're going to circle this electron, and it's going to be transferred to this chlorine because this chlorine wants 8. So now that's going to be there. This is going to be a negative 1. This is going to become a positive 1. So our formula is just going to be LiCl, and we're going to learn how to name that next week. So let's do one that's unbalanced. So our strontium and oxygen is going to be balanced, calcium, bromine. Let's do let's do beryllium and nitrogen. So beryllium is Be. It's in group 2, so it's going to have 2 valence electrons. Nitrogen is going to have 5 valence electrons. So this wants to get to 8, so it's not happy. This one wants to get to 8. They're both not happy. So this nitrogen is going to say, hey, beryllium, why don't you give me some of your valence electron? It's going to be like, okay. So it's going to go there. This one's going to go here, right? So now this nitrogen is still unhappy, but this beryllium is like elated because, you know, he has 8 now because he just lost his 2 that he had. This nitrogen still needs 1, so that means that we have to add another beryllium. It's going to go there. So now this nitrogen becomes happy, but this beryllium is sad, so then we got to add another nitrogen. with 5 more dots. Okay, now this beryllium's happy, still sad, but if we had 1 more beryllium, this nitrogen can absorb both of those. So our formula would simply just be Be123 N2. There's also a very simple way to do that if you don't want to draw the dots. I'll do it with the rubidium and oxygen real quick. So rubidium is Rb, so it's 1 dot, so it's going to be Rb plus 1, because it wants to lose. Oxygen is going to be a 2 minus, because it wants to gain 2. You take these numbers and you just flop them. So you're going to have 2 rubidiums and 1 oxygen. Hopefully that helps. It gives you a little bit of notes to do to help with this work. If you need anything, please reach out, and I'll do my best to assist you.